JANZZ.technology, the podcast.
Hello everyone, welcome back to the JANZZ.technology Podcast, where we explore the fascinating ways AI and semantic technology are transforming HR and job matching. I'm your host, Laura Flamarich, and today we are going to dive into a really interesting topic in the world of artificial intelligence and machine learning, data drift. To help us explore this topic, I'm joined by two amazing guests, Alejandro Jesús Castañeira Rodríguez, our principal data scientist, and Felipe Andrés Araneda Zúñiga, our junior data scientist. Together, they bring a mix of experience, insight, and curiosity to the conversation, as we will be diving into the topic of data drift, exploring what it means, why it matters, and how it is applied within the human resources field.
Thanks, Laura. I am happy to be here in the podcast again and to discuss more about the challenges organizations face when maintaining machine learning models in production.
Thanks, Laura. I'm glad to be here as well and to share some insights about this topic.
Thank you both for being here. So let's start with the basic. Alejandro, what is data drift?
Data drift refers to a change in the statistical properties of the input features that a machine learning model receives in production compared to the data that it was trained on. In other words, training data becomes different from inference data, even though the underlying relationships between features and the target variable might remain constant. This shift can degrade the model performance because the assumptions made during training no longer hold true when models face new evolving patterns in a production environment.
Okay, Alejandro, your explanation sounds quite technical. Could you give us some real-world examples about this?
Sure. For example, in healthcare diagnosis, a model predicts the likelihood of a disease based on patient data. If a new disease appears or a medical treatment changes, the patient's outcomes or the population health characteristics shift, the model's predictions may become less accurate. This happens, for example, with COVID-19. Most of the existing machine learning models developed before that date had no idea about this disease. So it was really impossible for them to make accurate predictions while in production. Another example would be in fraud detection in banking. A model that flags suspicious transactions is not able to keep up automatically with the constantly change in the criminal tactics. So the pattern of normal and fraudulent transactions are constantly evolving. So this model should try to evolve at the same pace. A more generic problem is what happened with large language model. For example, if you train a large language model with data before a certain date, let's say 2023, you will most likely don't know about current events. You cannot ask him actually questions about actuality topics, current policy shifts, or any type of novel vocabulary. So the idea is that you can detect this drift in productions and you can always try to keep your model up to date. Either if you retrain them or you just look for an alternative knowledge source so that the language model can give proper answers based on the actual context.
Okay, that's fascinating. I think many people assume AI just updates itself, but it doesn't. So how do we make sure models don't get stuck in the past? Felipe, what's the solution?
You're right, Laura. Models don't magically keep up with reality on their own. What worked yesterday may not fit today. To manage this, we use drift detection methods that continuously monitor incoming data. We compare it against the statistical reference we built during our model training. When the new data starts to diverge from that reference, we can flag it right away. That tells us it may be time to retrain our models with validated examples. This keeps the models precise, up-to-date, and aligned with changes in the labor market. It also gives us insights into emerging trends or shifts in role definitions.
Okay, so let me see if I understood it well. Felipe, you are saying that the system keeps checking if the world has changed compared to when the model was first trained. And if it has, you retrain it so it stays accurate, almost like a regular health checkup. but for AI models.
Exactly.
That's great. So I'd love to go a bit more deep to the technical side. Could you walk us through how you detect these drifts in the data step by step so our listeners can get a sense of the process behind it?
Yes, for detecting these drifts, there are several approaches we can follow. The goal is to analyze deviations in textual data. The first step is to convert the textual data into a numerical representation. To do this, we use a machine learning model called Sentence Encoder, which has been pre-trained to represent the meaning of sentences. Next, as a second step, we apply Principal Component Analysis, or PCA. PCA is a dimensionality reduction technique. It compresses high-dimensional data into fewer components while preserving key variations. For our purposes, we use it to build a reference, which is a statistical representation of the data we already know. New data will be compared against this reference. But how? We do it by projecting new data into this PCA space and calculating a reconstruction error. This error measures how well this new data fits the established reference. A low error means the data fits that reference, and a high error signals potential data drift. PCA is valuable because it provides a compact representation of data and a quantitative way to track changes over time. It turns subtle differences into measurable deviations, helping us identify when new data diverge from our established reference.
Felipe, I appreciate how technical your answer was. I think our data science listeners will love that. But for everyone else, could you explain the same idea in simpler words, maybe with an analogy, and even give us some concrete HR example so our listeners can really picture it?
Yes, let's say in our set of knowledge, there are lots of job ads for digital marketer, content writer, social media manager, and so on. But then, suddenly, we get a job ad for a brand new job title, which is TikTok Growth Manager, full of keywords like short-form video strategy, creator partnerships, and TikTok ads. For these situations, our system detects that the job ad looks very different from the known patterns, and therefore classifies it as far from known jobs, meaning it will be marked as data drift.
Okay, so once you've identified the data drift, what happens next? If you're seeing drift regularly, that must mean like a huge amount of data. So how do you make sure you focus on what's most relevant instead of getting lost in all the constant change?
Every day at JANZZ, we process millions of data points. This can be job ads or candidates' resumes. To handle this volume, we apply statistical techniques. The idea is like to identify redundancies in the incoming data and isolate the most representative samples, because it's not possible to correct manually all the drift. So basically what we try is to cluster them. After, we have our training data, and we also have the new instances, which are the drift samples that we found in a production environment. Let's say there is 1 million new records. We will try to cluster them so we get the most representative data. So maybe there are some drifts, they are based on new trends like TikTok, producer, or we have, especially in AI, we have many new terminologies like prompt engineer, data science, specializing elements. So we are trying to clusterize similar occupation or similar jobs, writing style, so that later our curators can concentrate in these ones a little bit better.
So, in other words, you're filtering out the duplicates and focusing on the signals that really show something new it's happening. So once you've identified drift and selected the most representative data, what happens next? Do you immediately retrain the models, or is there another step?
So after we gather all the drift data, we have millions of records. We cluster them, then we have the more representative samples. The next step is to retrain this data right away. Then we will give these clusters or more representative data to our domain experts. These domain experts at JANZZ work in many different languages, and they have extensive experience training machine learning models. These are the same curators that they carefully have been parsing and validating information to ensure that our models maintain the highest quality possible. They will manually annotate these records and correct the current model's predictions in all different languages. This process is known as supervised learning. After we have annotated all these new drift or cluster, the most significant element from each cluster of the drift data, then the new models will be more accustomed. So they already knew the new shapes in the market. So when there are new terminologies coming, then let's say we see TikToker producer again, or we see element developer. So these new points will not be flagged as potential drifts or unknown data samples because our model already learned these patterns.
Okay. And how often do you actually see drift in practice? Is it rare or happening all the time? And does drift always mean something bad? Or could it sometimes reveal a cool trend, like spotting new skills before anyone else?
Okay, we see drift all the time because labor market data change fast. It's not just about new occupations appearing, but existing roles also get described in new ways. For example, one market may say social media manager, another may call the same job digital engagement lead. These lexical and semantic shifts change the feature distribution the model sees in production. Drift detection helps us measure those deviations from the training data. By catching them early, we keep the models consistent and aligned with real labor market data.
That makes sense for English jobs. But since you're working across multiple languages, how does drift detection handle those differences? Are some languages harder than others?
That's a great question. Instead of looking at the raw words, which can vary a lot across languages, we transform the text into a vector, which is a list of numbers that captures its meaning in a mathematical space. To do that, we use a multilingual transformer model. These models are trained to place semantically similar text close together. So, the Spanish term gerente de redes sociales and the English social media manager would be represented by embeddings that end up very close to each other. This allows us to detect drift consistently across languages. We are comparing meaning rather than surface-level words. It's still complex. Some languages are especially challenging because of their unique linguistic structure. For example, languages like Arabic, Chinese, Japanese, Indonesian, or Thai often present additional challenges, and sometimes they require a special treatment to be handled properly.
Drift detection really sounds like a crucial piece in keeping models accurate and reliable over time. Without it, you could end up with results that slowly get worse without anyone noticing. So it makes me wonder, if this is so important, why don't we hear more companies talking about it?
You are right, Laura. Drift detection is essential for maintaining the predictive performance of machine learning models. The reality is, many companies don't do it because implementing it requires advanced monitoring frameworks capable of handling high-dimensional data and constantly evolving data streams. Or companies simply ignore it. They train a model once, deploy it, and then assume it will keep working forever. That approach might seem easier, but over time their models degrade, predictions become unreliable, and clients lose their trust. At JANZZ.technology, we are ahead of the curve. We have developed end-to-end pipelines that integrate real-time data ingestion, statistical and embedding-based drift detection, and automated retraining triggers. This allows us to accurately quantify deviations from the training distribution, ensure model predictions, and maintain alignment with the evolving labor market. Sometimes, most companies don't even attempt, which is why they really fall behind.
How often do you make this?
So detecting drift in JANZZ, we have this in several processes. So far, we have been spoken about the processing of detecting drift in the parser, especially when we find new job tasks, new resumes, and ways of describing them. There is another process that we have to detect drift in daily basis, which is the JANZZ ontology. As we have discussed previously in the podcast, we have JANZZ, which is the world's biggest ontology of human resource data. It's available in several languages and has more than 1 billion relationships and related concepts. So the idea basically is every day there are some new occupations entering the ontologies. These occupations will land in the not categorized concept. And our team of curators will categorize this into one of the JANZZ concepts. This process occurs in daily basis. So every day we do some, let's say, drift inspections in that sense. The other process that we were describing was the parser detection. Basically, the parser review or the retraining our models takes place at least once a month. The idea is every time we have considered amount of data, let's say more than 100 annotations in one language and one mode, we will retrain our model. We try to keep it more or less around this number to be statistically relevant. So we have a trigger that every time we collect new data, we do all the reclustering, reshifting, retraining, and a new model is deployed. In this way, we always try to keep the production environments as relevant as possible.
Okay, so it's really up to date. And this limit that you're mentioning is in every single language?
Yes, basically in every language, in every mode, because we do analysis of job ads in English, job ads in Spanish, CVs in Romanian, cover letters in Chinese. So it's good to know that in JANZZ we have one specialized model or several specialized models for each one of these use cases. So we detect drift in all of them individually, and we retrain this model every time there is a new amount of data in one of these modalities.
This is great. It really looks like here at JANZZ.technology, you are doing an excellent job and staying on top of these challenges. So, to sum it up, drift detection keeps our models relevant, our matches fair, and our clients happy. Before we wrap up, what's the key takeaway for our listeners?
Drift detection is what keeps AI systems reliable over time. In our company, we use drift detection to make sure that our machine learning models adapt perfectly as the data evolve.
Exactly. It's a cornerstone for building AI that remains accurate, trustworthy, and future-proof. I think consistency over time is the most important feature that you can offer in a machine learning model running in production. It's about maintaining. It's not about accomplishing some metrics like precision, recall, or F1 score during the training stage of a machine learning model, and then we call it a day. The idea is to be consistent over time with these metrics so your machine learning models will always remain accurate in a production environment.
Exactly, which is why at JANZZ.technology, we constantly monitor and refine our products so our clients get the best possible matches every time. Alejandro and Felipe, thank you so much for this insightful conversation.
You are welcome, Laura. I am always happy to talk about this.
Thank you. It was a pleasure. And don't worry, Laura. Next time we'll try to make drift detection sound a little less drifty.
I'll hold you to that. If you'd like to learn more about how we keep our system up to date and deliver top results, visit us at JANZZ.technology. Thank you for listening and goodbye.